For those that need additional help with scaling, a reminder of what we went over in class. Scaling on an image from a microscope is very similar to scaling on a map. For instance, in this case of this map of British Columbia, you have a scale bar that represents 300 kilometers, and you have a variety of distances that you could measure. I'm going to say I want to know the distance of the length of Vancouver Island right here. So the kinds of measurements I would need to figure that out would be a ruler measurement of the scale bar, and so what that would be in centimeters. And remember, on the ruler you can estimate down to the hundredth of a centimeter. And then a ruler measurement of the length of Vancouver Island. And from those things you can actually set up a proportion. So things that you would do and write down would be, well, I know my scale bar represents 300 kilometers. I know that the ruler measurement of my scale was about 5.25 centimeters. The ruler measurement of my image object, which in this case would be Vancouver Island, would be 7.10 centimeters. And then I can set up a proportion to solve things, to figure things out. So the ruler measurement of the scale to the scale would be equal to the ruler measurement of the image object to its unknown value in real life. And then if you remember from math, what you do with proportions to solve them is you actually cross multiply. And so let's set up our problem now. 5.25 centimeters is to 300 kilometers as 710 centimeters, 7.10 centimeters is to x. Does everybody see where I got those numbers? Okay, here was the ruler measurement of the scale, which came right here, and that goes here. The scale value is 300 kilometers, and that goes here. Ruler measurement of the image object, which is the size of that island, was 7.10 centimeters, and then we're solving for what it is in real life. All right, so cross multiplication, 5.25 centimeters x is equal to 300 kilometers times 7.10 centimeters. And then to isolate x here, we need to now divide by 5.25 centimeters, which means we need to do it to the other side as well. And then we can cross out accordingly. You will notice on the right side the units. We are also able to cross out the centimeters over here. Okay, so if we multiply and divide, we get an answer of 406 kilometers. This same process can be applied to a microscope image. We have a scale bar. We have a scale bar representative number. In this case, it's 20 micrometers. And we have an image object that we want to measure. And all of you have a picture that you need to do this with. So you measure the scale bar with a ruler, you measure your object with a ruler, and you go back and you plug in to this proportion or a similar proportion. There's different ways to set it up. And you solve for x to get your answer, and this answer number represents how large your object is in real life. Now, some of you might have a different value other than micrometers. This is that weird mu, that's the Greek letter mu, is a shorthand for micrometers. Some of you might have nm, which is nanometers, and some of you, a few, might have angstrom, which is a capital A with a funny little 0 on top of it. It doesn't matter, you can still solve, and your unit will end up with whatever unit this is, just like in the case of here that the centimeters cross out and you're left with kilometers. The centimeters are going to cross out and you're going to be left with either micrometers, nanometers, or angstroms, depending on what you have. And then we're going to use this number to fill out a different proportion to figure out how large your object will be in the room. All right, I'll walk you through that part in part 2 of this. Thanks, guys. Bye.